All right, so we basically touched on a little bit about how to use inverters to make NAND gates and stuff like that. That was the previous section. So what I want to talk to you about right now is what we call the logic gates, the packaging of it. So first of all, TTL stands for, so I want to tell you TTL again. TTL stands for, remember I talked about this, transistor, logic, and CMOS is complementary metal oxide, so complementary metal oxide semiconductor. So on a integrated circuit, what we call an IC, and there's some nicknames to it, some names we give it, such as a bug. They come in different packages. They come in 6-pin, they come in 8-pin, they can come in 16, etc. And they go all the way up to 120, 22. So when we look at an integrated circuit, when the book does talk about this, so what we basically have, I'm going to draw this a little bit better here. Draw this over this way. There we go. So basically what we have is a chip. So we have a little indentation. So it could look like that, or it may look like something like this. So there's two ways to identify it. Actually, there's multiple ways to identify it. And I'm going to do one more down here. There we go. So anytime you see this bump right here, this little bump, this is always indicating pin 1's to your left. So if you have this little bump and it's pointing to your left, that's pin 1. That goes, let's say this is an 8-pin, 16 pins, so that goes to 8, and then this goes to 9, and then that'll go to 16. So this is called 16-pin DIP, dual inline package. DIP is dual inline package. DIP is dual inline package. And then this one, if you look for like a little indentation, a little circle, again, that points to pin 1. Let's say that's 8, that's 9, and there's 16. Now, on these square ones, they're a little different. Usually they'll have like a little area that's been cut off, that's on an angle right there. And that's always going to point to pin 1, and it's going to go all the way around. So let's say this is 128. So look for that little indentation. When you find these are on CPUs, that's central processing units. You see these a lot on the Intel central processing units, etc. Now, you probably ask yourself, is there a difference between through-hole or service mount? Let's talk about through-hole and service mount. Through-hole means that when you have a board, let's take a side, let's say this is your side view of the board, of your printed circuit board, this is PCB. A through-hole means that when you put a component on there, it feeds through that hole, right? Well, how if I get that? There we go. Feeds through. So basically, it's just sort of, this is your PCB. And this is going to feed through, so it's going to feed through here. Say a little dotted line, it feeds through. And what we're going to do is we'll solder on this side right here. This is called through hole. Nice thing about through hole is that the parts really is easy to get in there because you bend the leads and they hold. The bad side about it is that if you try to pull them off, it becomes a little more problematic. On service mounts, I'm going to draw this on the side again. On service mount, if we have a component, let's say we have a integrated circuits right here, IC. The leg, what we call the legs or the pins, are going to be right on the surface right here. So they're going to be on the surface right there. So on the service mount, this is SMT, this is through hole. And this is service mount technology. This is what we use today quite a bit. We still use PCB through hole, but very rarely you'll see PCB through hole. You'll more see PCB SMT. That's printed circuit board SMT. And the nice thing about SMT is that we lay these on top here, and then we can solder right there. And you'll learn how to solder these later on. So both the printed circuit boards and the one's through hole and one's SMT. Soldering we'll talk about later on, and desoldering. That is an art itself. One thing you want to pay attention to on any of these integrated circuits, whether it's surface mount or if they're through hole, is that we want to make sure that that we follow the correct pattern on where pin 1 is, because that is important to understand where voltage, ground, and all the control signals are at. And I'm going to show you that in a second. So as you see this, let's say this is an AND gate. This is an AND gate, 7408 AND gate. So this is the pin numbers on it. Here's pin 1, because remember I said pin 1 is always, when you're looking at it, it's always going to be to the left. And if you're looking at this at the way we're doing, it's going to be the top number and works down to number 7. And then we have number 8. This is actually a 14-pin dip. So we can look at 1A and 1B are our inputs, and then 1Y is our output. You notice we have to have ground and we have to have VCC. So VCC and ground dictate how much voltage we have. So if we were going to hook up this type of circuit to our breadboard, what we would want to do is take this integrated circuit, put it into the breadboard, and then we're going to take some little dip switches, and those are dual in package. Dip is dual in package. And we're going to connect up our battery to one side of it. And you notice we have battery power to pin 14, and then pin 7 is ground. And then what we're going to do is take pin 3 and move it to that LED. Remember that little circuit I drew? Well, it's similar. I just put the resistor, which is more common, to put it on the anode side. That's this side, then the cathode. Then we ground it. But this is important here. There's 2 switches. So we have 2 switches. Well, we tied the switches to highs and also tied to ground. So if it's up here, that means these pins are going to pin 1 and pin 2 are going to receive 5 volts. If it's down here, these are switched down here, that means they're going to be ground, so they're going to be 0. So that's how you look at and you study a integrated circuit. And this is basic schematic. This is the schematic. This is the almost like a diagram, a wiring diagram for it. Finally, on this, I wanted to say that if you're not sure what the chip is, look on top. And you usually see like a DM, you might see an LS, you might whatever, but you're looking for unique numbers, 7408, 74139, 138, whatever. But you're looking for those unique numbering on that. Finally, CMOS. CMOS is, you have to understand CMOS itself is static sensitive, and it's because of its construction. And they're much better than TTL, and they're more expensive. But TTL, more expensive, CMOS, less expensive, but CMOS itself is static sensitive. Both are really static, but this one really is static sensitive. So if you actually even if you don't think you have any static electricity, you hit those pins, you can actually do some destruction inside the integrated circuit. So just keep that in mind. Similar packaging, CMOS will actually have a CD on it, and it's usually a CD 4081, etc. When you're using those, you have to remember that you're using a static sensitive device. So what you want to do is use a wrist strap for that. So that just gives you an idea. Similar pinouts, instead of using VCC and GND, they're using VSS and VDD. So VDD are your voltage and VSS is your ground. If you're not sure, usually there's a spec sheet or called a data sheet will tell you that information.